Hello, this is Gene Millard, your moderator for this special presentation that we'd like to thank Farm Journal Media and Chevron for bringing some great material for you in the audience, and we thank you, the audience, for attending this. To ask questions throughout this presentation, you can do so by clicking on the Ask a Question button that's below on the screen, and we'll answer the questions after the presentation. If you don't see the button, you're probably in full screen view, so just hit escape on your keyboard then, and you will see the button. So that's how we go. I'm president of Millard Family Farms out of Osborne, Missouri, a farm broadcaster of many years, and a communicator as best we can in the agricultural community, and glad to be with you here today. I'd like to have you introduce to you our presenters today, Dan Holdmeyer, who's the industrial sector manager with over 38 years of experience in the lubrication industry. Dan Holdmeyer has worked for Chevron for the past 18 years, serving in a variety of capacities with the company, and in addition to his current role of industrial section manager, where he manages product portfolios, sales, marketing strategies, and programs. Also, Shawn, Whitacre, senior staff engineer, has been focused exclusively on research and engineering, dealing with heavy-duty lubricants, fuels, and materials. At Chevron, he primarily is responsible for product formulation of the Delo brand of heavy-duty engine oils. Whitacre is also the chairman of the ASTM Heavy-Duty Engine Oil Classification Panel, which established the new specification requirements in December of 2016. A lot of good people here doing some good work with some good information for you. So, Shawn, take it away.
Thanks, Gene, for the introduction, and thanks to those of you who are listening in. In today's webinar, Dan and I will be covering some recent changes in diesel engine oils. I'll be explaining what motivated these changes, what exactly changed, and in fact, a few things that didn't. But most importantly, we'll discuss what this all means to you and to your farming business. I hope that you'll find that there's actually a whole lot to be gained. Then later on, we'll be fielding questions about what we talked about today. So use the click on your screen to send those in while we go through. So what's new? By now, you've probably at least somewhat aware that the new American Petroleum Institute has recently instituted a new heavy-duty engine oil performance specification. In fact, this time there were two specs. We'd like to take this opportunity to help you better understand these new performance requirements and how they'll impact the agricultural market. We'll also spend some time addressing some misconceptions about the new oils. Some of you might be wondering what triggered the development of these new specs. Back in 2011, heavy-duty engine manufacturers formally requested the development of a new engine oil category. Although the primary motivation was driven by the need to improve the efficiency of on-highway diesel engines in order to improve their carbon emissions, the request was also endorsed by a number of the traditional off-highway equipment builders. Those include John Deere, Caterpillar, among others. The off-highway OEMs weren't faced with the same greenhouse gas regulations, but nonetheless, they saw the need for improved lubricant quality, including improvements in oxidation stability, aeration control, and shear stability. So effectively, they were asking for greater flexibility in the products that were being offered. So the challenge became, how do we upgrade the performance of traditional heavy-duty motor oils at backward compatible performance levels and viscosity grades while also providing new, lower viscosity offerings that deliver even greater fuel savings? There are, in fact, a number of advancements in equipment technology that are aimed at improved fuel efficiency, and you might be surprised that many of them are actually quite relevant to the equipment you run on your farm. These improvements range from new engine technologies to improved aerodynamics. Notably, it also includes engine fluids like engine oil and driveline fluids that do provide direct fuel economy benefits themselves. But you're probably thinking these regulations don't apply to the equipment that I run on the farm. And to some extent, you're correct. The focus of the recent heavy-duty fuel economy and greenhouse gas regulations are, in fact, primarily targeted at heavy vehicles that run on the road. But of course, they do also apply to light trucks and other vehicles that are used to deliver product, haul equipment, among other services. Off-road engines like tractors, drilling equipment, and the like are regulated for pollutant emissions, most recently through the Tier 4 final standards, which forced the eventual introduction of catalytic aftertreatment equipment. So SCR catalyst using DEF, as well as particulate filters that drastically reduce the levels of particulate matter emitted from these trucks. The primary way that engine oil improves fuel economy is through lower viscosity. So imagine, if you will, that you're rowing a boat, but instead of water, the lake is filled with maple syrup. You'd undoubtedly have to work a lot harder to get across the lake as you push yourself through this thicker, more viscous fluid than you would if the lake were filled with water. And the same is essentially true for the diesel engine. The engine oil steals a certain amount of energy that the engine produces to move this oil around the engine to lubricate the moving parts. The thicker the oil, the more energy that is in effect wasted to push it around. And in fact, this trend has been in place well before there were these new regulations. We've seen a steady increase in the use of lighter viscosity grades like SAE10W30s and a similar ramp down in the use of traditional SAE15W40 oils in the on-highway market for many years. In fact, we predict that within the next 5 years, there will be as much 10W30 sold as there is 15W40. That's at least the case for the on-road market. The picture, though, is much different in the off-highway, where OEMs still recommend and customers largely prefer the heavier oils. But we're also seeing a steady but much less drastic increase in these lighter grades, both because customers are seeking better all-weather performance, improved fuel efficiency, or because the customers don't want to use different oils in their off-highway equipment that they do in their on-road trucks. This category is not just about improved fuel economy. And we'll go into more detail later about the category itself, but I do want to emphasize that these improvements with these new oils do go beyond just fuel economy. Most notably, there are new performance requirements in place that demand better protection against thermal breakdown within the engine. This is due largely to modifications that engine builders are making to really stress the oil, especially when the engine is working hard in the dead of summer. Does that sound familiar to any of you? This too has a direct impact on oil life, enabling some engine manufacturers to actually extend the oil drain interval when these new oils are used. So as I mentioned earlier, we actually have two new categories in one. So hopefully some of you have become familiar with the previous engine oil category, what we called API CJ4. This performance spec was first introduced in 2006 and was the primary recommendation for OEMs in North America for the past 10 years. The first new category will be called API CK4, and it will be the ideal choice for off-road customers as well as mixed on-highway fleets that may not be ready to move to the much lower viscosity products. In fact, a large majority of heavy-duty motor oil today meets this new spec. But I want to point out that we also introduced a second, lower viscosity category that we call API FA4. And this category is aimed at the newest model year on-highway engines that are designed to take advantage of this new oil and deliver optimized fuel economy. As we'll reinforce later, this lower viscosity oil is generally not recommended in the off-highway equipment, and for the most part isn't recommended for any older equipment, even older truck engines. So when in doubt, stick with API CK4. What I'm showing here on the screen are what we call the API donuts. These are the service symbols that help you identify the performance category that your engine oil is licensed to. You'll note that even the design of the FA4 donut is different, in this case with a blacked out quadrant to help further distinguish those products. And this distinction is important, especially when you're selecting engine oil viscosity grade. What you'll note here is that API CK4 oils, as was the case with API CJ4, are offered in a variety of viscosity grades, including conventional 1540s, as well as some of the lighter viscosity grades like 10W30s and 5W30s. These oils must have what we call a high temperature, high shear viscosity. HTHS is actually easier to say. That is no less than 3.5 centipoise. This is the same minimum requirement that has been in place for the older categories for at least the last 20 years. So what makes FA4 different is that this limit doesn't apply. In fact, FA4 oils are required to have a lower HTHS, one that is between 2.9 and 3.2 centipoise. These are levels that on-highway truck makers know bring added fuel economy. You'll note, however, that certain SAE grades can be either a CK4 or an FA4. So it's as important as ever to acknowledge both the viscosity grade and the API spec that is recommended for your equipment. So you might be wondering what this HTHS viscosity relates to. So in simple terms, this is a measurement that is made that is particularly important because it defines the operating viscosity of the lube oil. This sort of best represents the temperatures and the shear rates that it encounters inside critical engine components like overhead, power cylinder, and the bearings.
Hey, Shawn, I'd like to interject a little bit here. I'm originally from Missouri, so I got a little show-me mentality and like to try to draw a picture of what we're talking about here. When you're talking about that high temperature, high shear, or HTHS, particularly in the SAE something W30, whether it's 5W, 10W, or 15W30, you have a high temperature, high shear of one viscosity, and then the FA4 has a lower high temperature, high shear, and you're saying they're different viscosities, but they're both 30 weights at operating temperature. So I'd like to kind of draw a visual that someone taught me years ago. If you're looking at a 10W30 or a 5W30, just like your maple syrup example earlier, when it's cold, it acts like a 5W. It's not really real thick, but it's still like a 5 weight. It still thins out when it heats up. It turns into a 30 weight. So it thins out to that of only of a 30 weight, not staying as a 5 weight. And how we do that is we put some large polymer molecules in there that are kind of coiled up on themselves like a hairball, a bunch of hair mixed up together, and it kind of holds the oil together so that at low temperature it kind of shrinks and flows pretty easily. At high temperature it stretches out, and that's how you get that different viscosity grade. But when you see these roller pin areas, cam bearings and cam followers and places like that where there's a lot of shear and stress, that hairball tends to deform a little bit and kind of shrink back a little bit. And I think that's what you're talking about, the high temperature, high shear area. I kind of think of when my daughter came home and plugged up the drain in the shower with her long hair, and I just take a plunger to it, put a little stress to it, that hairball just kind of shrinks a little bit and is able to flow through there. It still springs back and gets to more viscous material as I relieve that stress and that shearing action. This is different than what used to be referred to as a permanent shear, where you had a 15W40 shear down, you have a 15W30 in the long run, where those polymers are cut in half or broken up in pieces. This is just a temporary shear. If I can use an analogy, does that kind of make sense to you, or does that work for you too, Shawn?
Yeah, absolutely. It really speaks to the types of components that are utilized in these engine oils as we formulate them to meet these new standards. It includes these polymeric, the hairball-like additives, as you described them, that really impart that viscosity temperature profile, and that allows the oil to have a sufficient viscosity regardless of its temperature and its operating environment.
Yeah, and I think there's a requirement, too, that it doesn't shear or permanently shear. So that's added benefit for this new specification.
Yeah, And that sometimes is referred to as shear stability. And as we'll point out later, there's some specs that actually require that. So, of course, if you don't formulate the oil properly, making an engine oil thinner will undoubtedly negatively impact wear protection. So when the oil is thinner, so too are the lubricating films at the surface of these parts. And as a result, the viscosity change must be accompanied by adjustments in the anti-wear and other additives that are used to protect the engine. It truly requires a careful balance of the right components. That includes the base oil, anti-wear additives, soot dispersants, the viscosity modifiers that Dan just described, as well as antioxidants. These components all work together to help the oil meet these new, and as we're going to point out here soon, very demanding new standards. So I'm going to spend a little bit of time describing what this new specification, or actually specifications, entail. So an important feature of these specs is that the performance requirements of the two categories are identical. I described earlier that the main difference between CK4 and FA4 are in fact of their viscometrics, but the actual performance, the tests that the two oil types have to meet are identical. The same tests, the same specification limits. They're required to undergo this extensive engine test battery that ensures product robustness, whether you're talking about a conventional 1540 or one of these new low viscosity FA4 10W30s. You might note that there are several familiar names on here: Cummins, Mack Volvo, Caterpillar, General Motors. All of these companies have developed standardized dynamometer-based engine tests. These 9 tests must be passed in order to qualify against the API standards. The specification includes requirements to pass several of the already stringent API CJ4 engine tests, and those I've indicated with the blue circle, as well as 2 new tests, one of which really stresses the oil and drives significant improvement in the oil's ability to withstand elevated temperature. And that's a feature that's important to both the on-highway as well as the off-highway customers. There are 4 tests that measure various aspects of wear control, 2 that measure piston deposit control, and others that control oil thickening both at high and low temperature, as well as a test that measures the oil ability to resist aeration. I'm going to spend a little bit of time talking about one of these new tests because it's a real doozy. The new Volvo T13 is a 360-hour test. In this test, the oil is kept very hot, over 260 degrees F, for 360 hours. And if that's not enough, the engine is run at a condition that exceeds the standard rated condition with a very high peak cylinder pressure. And to make it even more challenging, the test runs with a reduced engine oil sump capacity. During the test, oil samples are periodically collected from the engine, and they're subsequently tested for oxidation and viscosity. And I'm going to show you an example of some results from tests of oils with varying oxidation stability. These are graphs generated from Volvo T13 tests, and they really illustrate the benefits that the new oils bring. As you can see, high-quality API CK4, as shown here with the black triangles, retains a relatively steady viscosity profile up to, and in this case, past the 360-hour limit of this test. Oils that were formulated to meet older performance specifications, like the API CH4 category that was introduced nearly 20 years ago, break down significantly earlier. And that's noted by the very drastic increase in viscosity that you see at around 175 hours for the CJ4 oil, and as early as 100 hours for that API CH4 oil. We talked earlier about wear protection at thinner oil films and the increased importance of boundary lubrication protection. These are wear films that we can now see by using sophisticated analytical tools. So here we're comparing the wear protection barrier that's established on the face of a flat tappet. That's the picture on the left showing a conventional technology where this film is inadequately formed, compared to the right with an advanced formulation that lays down a protective surface that helps to defend the component from wear.
So, Shawn, can I interrupt again? This kind of reminds me, or does remind me of zinc dithiophosphate, or commonly referred to as zinc, as the anti-wear package. A lot of folks are out there saying we've had to get rid of the zinc, which we have, lower the phosphorus levels, lower some of the calcium, take some of the metals out of the oil itself that are good additives to protect the after treatment or the catalytic converters after the engine. And we're hearing this out there in the field, and people are saying, hey, the oil companies had to take out the zinc for environmental reasons, and you're getting less wear protection. But this seems to show just the opposite, that we're actually utilizing different additive chemistry that's not metallic-based and giving better wear protection. Is that what we're seeing here?
Dan, I'm really glad you asked that question because you're absolutely right. And this actually dates back over 10 years ago when we first introduced the API CJ4 category. And that was really geared towards making the oil compatible with these new emission control systems. Those are the ones that started to be used on truck engines in 2007 and are now used in farm equipment meeting Tier 4 interim and Tier 4 final standards that are in place today. Those required reductions in sulfur and phosphorus levels from engine oils, not completely gone, but dropped to levels that the emission control systems are compatible with. And we've counterbalanced that reduction in traditional anti-wear componentry with new non-metallic chemistry that does provide the same, and in many cases, more robust protection than that older, more conventional technology provided. It really is a balancing act of a number of different components that deliver on this performance requirement, not just phosphorus alone.
So it's not necessary then to be adding these supplemental anti-wear additives in there. In fact,
absolutely. These oils are formulated to work as delivered, and in fact, they're careful balances of all these components. And supplemental additization, in most cases, provides more harm than good. This is actually one area that supplemental additization can disrupt, and it's an area that we refer to as deposit control. And piston deposit control has been an important in defining oil performance for many years, but I think that the stakes are even higher now. So with the recent adoption of new catalysts and exhaust PM filters, oil consumption control is more important than ever. And when these deposits are allowed to build up to the point that they begin contacting the surface of the liner, or if they in fact interfere with piston ring travel or sealing, oil consumption can drastically increase. And we've seen in situations where there's a loss of oil consumption control that this can increase the rate of contaminants that eventually poison or plug the emission control system. And that requires premature and in many cases more costly maintenance to keep those emission control systems and the engine itself running as it was designed. We spent some time talking earlier about all of the engine dynamometer tests that we run to prove the performance of these new oils. And engine dynamometer testing is actually very important, but we also realize that it's no substitute for the proof of performance that is demonstrated by getting the products into customers' hands and learning together with them about the advantages of the new oils. So as you'll note here, we embarked on the most rigorous and I'd say varied field test program in our history. We put the new products in nearly 1,000 engines in a variety of equipment types. We're testing in almost 500 on-highway trucks across a range of builders. But for the first time ever, our new product field test program included a significant number of off-highway pieces of equipment as well, including tractors, dozers, and hard-working farm trucks, just to validate these benefits in real-world applications, the way customers use them, and exposed to the types of conditions, climates, and operating cycles that is most relevant to the variety of end users that purchase these products. For example, we've been testing at a construction site that had been using an SAE 15W40 API CJ4 oil. In this trial, they converted some of their units to a new API CK4 SAE 10W30 oil. And despite using the thinner oil, they've actually seen a reduction in the level of wear metals in their used oil analysis. Clearly, the new oil is providing improved wear protection. So what does this mean for the ag market? So ag OEMs and farmers clearly could benefit from the improved oil oxidation, which leads to extended drain protection for use in new generation oils that protect the Tier 4 equipment, but as well as in older hardware. The new API CK4 products are offered as a 15W40, just like the CJ4 oils were before, and that still remains the primary recommendation by most non-road OEMs. These new API CK4 oils deliver improved engine protection through improvements in wear control, piston deposit control, as well as that oxidation control driven by that new Volvo test. So where do you go from here? So I'd suggest that, you take this information and understand that it really is a quality upgrade. You may not be ready to explore a new viscosity grade, but you're still going to get performance benefits. And this new API CK4 category is backward compatible for use in your older vehicles. Always make sure that you're following OEM guidelines for the API spec and viscosity grade that's recommended for your applications. It's a great time to conduct a comprehensive review of all the equipment in your fleet, not only the types of equipment, but the model year, the emissions level, to really ensure that you're carrying the right oil. You might find, in fact, that you can consolidate to fewer number of products and take advantage of the backward compatibility of these standards.
On that backward compatibility, and you mentioned following your engine specifications, API C, unless you have a new engine, it's not going to say CK4. So if it says CJ4 or CI4 or something like that, this CK4 category supersedes that. So it is a replacement for that CJ4 and would meet the OEM's requirement. Okay.
Yeah, good. And that's precisely what we mean by backward compatibility, is that API CK4 requirements include all of the old requirements as well as the new ones. And so if it recommended CJ4, maybe you've got a piece of equipment that's 20 years old and the manual still recommends something like a CH4 or what's now an obsolete category, CG4. These new CK4 oils will still fit the bill. So hopefully you're a bit more familiar with these new API categories and the many benefits that these new oils can bring to the ag market. We've shown here that the improved wear protection, oxidation control, and deposit prevention offers the potential for longer maintenance intervals and engine life, both of which can impact your bottom line. At this point, I'm going to kick it back to Gene to see if there's been any questions submitted.
Okay, Shawn, thank you for the presentation there. I do have a couple of them I'd like to throw in. Just a reminder to ask a question by clicking on the Ask a Question button below on the screen. And if you don't see the button, you're probably in full screen view. So hit Escape on your keyboard and you should see the button. One is that, okay, I got a new truck. It's an 18-wheeler for hauling grain, and it's come factory filled with an FA4 oil. Will it void my warranty if I switch over to using CK4?
Yeah, that's actually a really good question, and one that we encounter a lot. And the answer is the OEMs that are actually factory filling with FA4, understand that in most cases they're selling product into mixed fleets. So it's either mixed fleets of old or new equipment, or in many cases, a mixed fleet of on and off highway equipment. And it's perfectly acceptable at the first oil change to transition one of those products that was pre-filled with FA4, transition it to an API CK4 of a different viscosity grade, if that's what makes more sense for your operation.
I think that kind of answered the other question that came in is, can I put an API CK4 in my older equipment?
Yeah, I mean, it's always good to check with your OEM about their specific guidance. And the only limitation there in certain instances is that some older equipment are not approved to use lower viscosity grades. They're in fact required to use SAE 15W40 oils. But from the standpoint of the API spec, using API CK4 is almost universally acceptable.
Well, another question is, we'd rather not stock or inventory multiple lube oils, so can I use an API CK4 oil in my gasoline-powered engines?
So in some cases, yes, you can. So oils that can be used in both diesel engines as well as gasoline engines are sometimes referred to as universal oils. And these are products that are suitable for use in both. So the key factor there is to not only look for a product that makes the API CK4 claim, but also the API SN claim. It's those combination of specification requirements that ensures that the product is suitable for use in both a diesel as well as a gasoline engine.
Okay, well, on our farming operation, we have multiple generations of engines out there with our equipment, both tractors and combines. And of course, with the extended hours we're putting on these equipment right now, we're concerned that we use the right kind of oil, whether it's tier 4, tier 3, or perhaps an engine that we don't even know what the tier is. Does it really make a difference?
No, and in fact, and it's part of what we addressed earlier is that these specs are deliberately developed to be backwards compatible. So even the tier 4 final equipment, that's kind of the lowest emission category right now for the off-highway market, we had that in mind back in 2007 when we introduced API CJ4. And that's what has that lower level of ash content and the lower sulfur and phosphorus to make it compatible with the after-treatment equipment that were used in on-highway equipment introduced in that year, as well as the Tier 4 final products that were started to be introduced kind of in the 2014 timeframe.
Well, Dan and Shawn, a lot of good information. I think all of us are wanting to get as many hours of productive use out of our investment in our power sources and engines, whether it's trucks or tractors or combines. And we certainly want to make sure that we get the maximum number of hours of the best lubricity that we can find in the oils that you guys provide for us with the right kind of specifications. So again, thank you, Dan. Thank you, Shawn. We appreciate your being with us, and we appreciate you in the audience. And if we didn't get to your questions, we will answer it by email within the next week. This presentation will be available online at agweb.com. This is Gene Millard saying so long.